Welcome to the first video, chapter 5, my favorite chapter in calculus for this year. Granted, I like calculus in general, so, but this chapter is the best. So we're going to start off simple with Rolle's theorem and mean value theorem. So these theorems are kind of an introduction into applications of derivatives. So we've done derivatives using power rule, general power rule, chain rule, quotient rule, product rule, implicit differentiation. So now we're going to start applying those to some more applied mathematical problems. So in Rolle's theorem, we're going to start there. It says, let f be continuous on the closed interval, ab, and differentiable on the open interval, ab. If f of a is equal to f of b, then there is at least one number c in ab such that f prime of c is equal to 0. So one, we use continuity here, okay? So the function has to be continuous, and it has to be differentiable on the open interval. What they're saying here is that if we have 2 points that are equal to each other, as in the photo, so f of a is equal to f of b, then there is at least one number c at which f prime of c is equal to 0. Notice here they draw c where it has a horizontal tangent line. Okay, so the instantaneous rate of change at that c is equal to 0. Okay, so let's look at some examples with that. In 10, it says f of x is equal to x squared minus 5x plus 4 on the interval 1 to 4. So a is going to be 1, 4 is going to be b. So I need to first make sure that Rolle's theorem can apply. So I have to look at my function. Is it continuous on the closed interval 1, 4? Well, this function is a quadratic, which means it has a graph of parabola, and parabola's domains are all real numbers, so yes, it is continuous. And then is it differentiable on the open interval 1, 4? Well, if I take the derivative, is there at any point where anywhere in 1, 4 that creates a problem? And that would be no, because the derivative is a line, okay? So it is differentiable. So I can use Rolle's theorem. The last thing I have to check, though, is make sure that f of a is equal to f of b. So is f of 1 equal to f of 4? So I do f of 1, which is 1 squared minus 5 plus 4. That is equal to negative 4 plus 4, which is equal to 0. So we have to make sure f of 4 is also equal to 0. So f of 4 is equal to 4 squared minus 5 times 4 plus 4. So this would be 16 minus 20 plus 4. This is also equal to 0. So f of 1 is equal to f of 4. Good. So now that I've met all the conditions of Rolle's theorem, I can now apply it, which says that there must be some f prime of c, which is equal to 0. So first thing I have to do is take the derivative. So f prime is going to be equal to 2x minus 5. And I'm going to solve for the c that's equal to 0. So I'm going to set this equal to 0 and solve for x. So 2x is equal to 5, x is equal to 5 halves. So I'm going to say let c equal 5 halves. Now, make sure that that c is in between 1 and 4. So let's just double check. 5 halves is greater than 1, but less than 4. So we're good, okay? Let's look at another one. So 6 gives us a function f of x is equal to x times x minus 3, and they want us to see if we can find an interval in which we can apply Rolle's theorem. So the best way to do this is to look for x-intercepts, okay? Because then we can assume x-intercepts means that both those x values is equal to f of x equals 0, right? So then they must be equal to each other. So I'm going to set f of x equal to 0. I read off my x-intercepts, which are 0 and 3. So my interval is going to be from 0 to 3, where 0 is my a and 3 is my b. And the reason why I do it in this order is because it should always go in increasing order. Okay, so a should be less than b. Now that I have my interval, I gotta check a couple things. Is the function differentiable on the open interval 0, 3? Yes, it is. Is the function continuous on the closed interval 0, 3? Yes, it is. So now that I've done that, I need to see if f of a equals f of b, but we know that because f of 0 is equal to 0, which is equal to f of 3. So I've met all my conditions of Rolle's theorem, so now I can take the derivative and see where it equals 0. So I'm going to recopy f of x. Now, As the function is written now, I'd have to do product rule for the derivative. But it'd be easier if I just distributed. So really this is x squared minus 3x. So now I'm going to take the derivative of that. So f prime will be 2x minus 3. Set that equal to 0 and solve. So 2x is equal to 3, x is equal to 3 halves. 3 halves is in between 0 and 3, so let c equal 3 halves. Now let's look at the second theorem in this section, which is called the mean value theorem. So the mean value theorem says if f is continuous on the closed interval ab and differentiable on the open interval ab, then there exists a number c in that open interval such that f prime of c is equal to f of b minus f of a over b minus a. Okay, so in mean value, it's very similar to rules in that your function has to be continuous on the closed interval and differentiable on the open interval. But the difference here is that now we're going to set our instantaneous rate at f prime of c equal to our average rate of change. So instantaneous rate at c equals average rate of change over the interval a, b. The other thing is make sure, again, c is in between a and b. Okay, and so what we're essentially doing, because average rate of change takes the slope of a secant line, right? We're going to take the slope of the secant line, seen here in pink on this picture, okay? And then they're going to find a line that is tangent to our graph, but has a parallel slope. Okay, so we're going to make sure the slopes are equal to each other, just one is a secant, and then what we're looking for is the x value that allows us to have a parallel tangent line to that secant line. So then let's look at some examples. First, let's look at 30. They give us the interval, and it says f of x is equal to x cubed on the interval 0 to 1. So first things first, is it continuous on 0, 1? Yes, it is. It's a cubic. It's going to be a smooth curve. Not going to have any breaks. Is it going to be differentiable on the open interval 0 to 1? Yes, again, its derivative is going to be simple, so it's not going to have any breaks in the graph, so we're going to be okay because the derivative is a parabola, so it should be differentiable. No breaks in the graph, no asymptotes is what I'm talking about here, okay? So then since we're continuous and differentiable, what we now need to do is find our average rate of change. So find the average rate of change. So it's going to be f of 1 minus f of 0 over 1 minus 0. So this is going to be 1 cubed, which is just 1, minus 0 cubed, which is just 0, over 1. So the average rate of change is equal to 1. And then we need to find the instantaneous rate. So f prime is going to be equal to 3x squared. And now we need to find the c that makes the following true. 3x squared equal to 1. So I'm going to divide both sides by 3. I get x squared is equal to 1/3. Then we take the square root, so x is equal to plus or minus square root of 1/3, which is equal to plus or minus 1 over square root 3. You don't have to rationalize. Now, are both of these numbers inside my interval? So, is negative 1 over square root 3 between this interval, 0 to 1? The answer is no. Okay, now I have to say, is 1 over square root 3 between 0 to 1? The answer is yes. So from here I say let c equal 1 over square root 3. Let's do one more, just for good measure. So this time in 34, we're given f of x is equal to x to the 4th minus 8x. And the interval we're given this time is 0 to 2. So again, my a is going to be 0, my b is going to be 2. First, we have to ask ourselves, is f of x going to be continuous on the closed interval 0 to 2? Yes, it is. Now we have to ask ourselves, is the function going to be differentiable on the open interval 0 to 2? The answer is, again, yes. Now we need to figure out what the average rate of change is. So average is going to be f of 2 minus f of 0 over 2 minus 0. So this is going to be 16 minus 16 minus 0 over 2. So this is going to be equal to 0. Now we have our average rate of change. We need to find our instantaneous, which is just f prime. So the derivative of f is going to be 4x cubed minus 8. And we need to set that equal to 0 to see for what values of x is that equal to 0. So we have 4x cubed is equal to 8. X cubed is equal to 2. So x is equal to the cube root of 2. Remember, when you take an odd root, you do not add a plus or minus. Now that we have our answer, we have to ask ourselves, is cube root of 2 going to be between 0 and 2? Well, we know that the cube root of 1 is equal to 1. We know that the cube root of 8 is equal to 2. So cube root of 2 is in between those two. So yes, the cube root of 2 is between 0 to 2. So let C equal the cube root of 2. And that's mean value theorem and Rolle's theorem. We will continue learning 5.1 on Tuesday. I think on the calendar it says 5.3, but we're going to do 5.1 next. And there will be PowerPoint involved with this, so I will put that up on Google Classroom as soon as I can.